Hello students, welcome to our today lecture. In our today lecture, we are going to apply the one-way ANOVA test. So basically, we apply one-way ANOVA when we have to compare the mean of more than one variables or more than one indicator. So in that scenario, we will be more interested to apply ANOVA test. So what is the null and alternative hypothesis? You can simply write it as that null hypothesis that all the means are not equal, and the alternative is that at least one mean is not equal. So null hypothesis should be all the means are equal, and the alternative hypothesis would be at least one mean is not equal. So here you can see that there is no significant difference in the math score across different program as we are using the data set of an organization. I will show you the data in our next step, that how to download the data that has been used in our today session. So the null hypothesis that all the means are equal, and alternative hypothesis mean that or in alternative hypothesis we can say that at least one mean is different or one mean is not equal to the other means. So these are the steps for our today's session. First of all, we have to check the normality of the variables, and we can check the normality of the variables by applying histogram and the Shapiro-Wilk test. Then we will be checking the variance of the variable, that for applying one-way ANOVA, these two conditions must be fulfilled, that data is normally distributed and the variance should be constant. But as we are interested to applying one-way ANOVA, so if our data is normally distributed or not, or our variance are not are equal or not, then we still go with our data set as just we want to do it for practice purpose. But when you are doing your research, you are working on any thesis, make sure that your variables are normally distributed and the variance should be equal. Then after checking the normality and the equal variance, then we go for ANOVA. So now let's do it by first by getting the data. So the data that has been used in our today's section, first of all you have to write HSB2 in your Google Chrome, and then this tab will open. So when you look at this tab, it tell you that the data that we have used in our today's session, gender, race and sex, program, right, math, science, and when you look at the down, you can see here that it has the data set of CSV file. So click on this CSV file, and then it will download it with in your systems. So after downloading data, go to the STATA and click on file, then import. And as you see that our data was in text data, so click on this text data, then sorry, go to file and click on import data and click on text data. So browse, and here you can see that we have downloaded our data as HSB2. So click on it, then submit, and now you can see that all our data is present here. So now look at the data set, go to data editor. So now you can see that our all data set is present here. So these are the categorical variables and these are the continuous variable. In program section, you can see that we have three programs like journal, vocational and academics. So we have three programs, so we will be doing analysis across these three programs. So now as you can see that the first step is to check the normality of the variable. So null hypothesis that variables are normally distributed, and alternative that variable math score is not normally distributed. So we can check it by histogram as well, and we can also do it by Shapiro-Wilk test. So now go back to STATA, and we can do histogram by command method as well, and we can also do it by you see that manual method as well. So let's do it by command method, and we will be doing it by manual method. So now you can see that it has given the histogram, but uh, we are not much clear that either data is normally distributed or not. So we will be applying Shapiro-Wilk test in order to identify that the data set is normally distributed or not. And then second thing is that if you do not want to follow this command, you can simply go to graphics, and here you can see that here is a histogram. In variables, you have to select the math. Then in by program, you have to select the program, and then in density plot, and here you have to click on add a normal density plot, then click on submit, and as you can see that it has given us the similar histogram that we have created with the help of command option. So you can do either by going to this option or by following the command. It's up to you which is easier for you. So now we'll be applying the Shapiro-Wilk test in order to see that either the variables are normally distributed or not. So for Shapiro-Wilk test, we have to copy this command, and the command is by sort program s-wilk Shapiro-Wilk math. Then go to STATA again and paste the command here. So now when you look at this result, it has given us the result according to three programs. First is academic, then general, and the last one is vocational. So for the acceptance and for the rejection of the null and alternative hypothesis, we have to see these p-values. Each program has its own p-value. And what is the null hypothesis? Null hypothesis is that variable math score is normally distributed, and alternative is that variable math score is not normally distributed. So if the p-value is less than 0.05, we will be rejecting the null hypothesis. And if the p-value is greater than 0.05, then we have to accept the null hypothesis. So when you look at the results for academic program, probability value is greater than 0.05. So which means that we have to accept the null hypothesis. It means that variable math score is normally distributed in academic program. But when you look at the general and vocational program, you can see that probability value is less than 0.05. So we have to reject the null hypothesis. So by rejecting the null hypothesis, we have to accept the alternative hypothesis, which means that variable math score is not normally distributed across general and vocational program. But as in our today's session, as I mentioned earlier, that we will be doing practice session. So we will continue with this. But if you are working on your thesis or your research paper, then it is not a good option to go forward from here, because it said that your data is not normally distributed. So first of all, you have to make your data normally distributed. But as in our today's session, we just want to see that how to apply one way ANOVA. So we will be going forward and assuming that our data is normally distributed, but in actual the data is math score is only normally distributed in academic program, but it is not normally distributed in general and vocational programs. So the next step is we have to check the that either the variance are equal or not. So the null hypothesis is that variance are equal, and alternative hypothesis is that variance are not equal. So how to check that either the variance are equal or not? We have to copy this command robust var, and robust var means variable, and the variable name is math by program. So we have to copy this command and we have to paste it in command window here. Then we have to look at W50 and we have to see its probability value. If it is greater than 0.05, then we have to accept the S0 or the null hypothesis. If it is less than 0.05, then we have to reject the null hypothesis. So what is the null hypothesis? Null hypothesis that variance are equal, and alternative hypothesis is that variance are not equal. And when we look at our probability value, it is greater than 0.05. So we have to accept the null hypothesis, which means that variance are equal and it is desirable. So we are done with the pre-test for applying ANOVA. We applied first histogram to check the normality, then we have applied the robust var to check the either the variance are equal or not. So the next is that we have to go for ANOVA. So what is the null and alternative hypothesis for ANOVA? That there is no difference in mean, or you can simply say at that all the means are equal, and alternative is that at least one mean is different or not all the means are equal. You can simply write it as all the means are not equal. So you can use any of these. So now we will be applying one way ANOVA on the math program. So here is the command. So one way math program, copy it and then paste it here. So now you can see that it has given us the result for one way ANOVA program. We have to look at this probability value. As you can see, that probability value is less than 0.05. So we have to reject this null hypothesis. So by rejecting the null hypothesis, it means that we are accepting the alternative hypothesis. It means that at least one mean is different. So this is how you can apply one way ANOVA, and you have to see the p-value, and if the p-value is less than 0.05, you have to reject the null hypothesis and you have to accept the alternative hypothesis, which means that at least one mean is different from the other. So the next thing is that how to identify that which mean is different. So now let's do it, but before doing it, we have to convert our math program into continuous variable as it is string variable. So we have to copy this command, encode program, then paste it here. So now you can see that it has created a new variable for program 2. And if you do not want to follow the command option for applying ANOVA, you can simply go to here statistics, and then you can also apply the ANOVA option from here as well. So when you navigate to statistics, go to linear models and related, and then go to ANOVA, and here you can see the option of one way ANOVA. So here you have to type your response variable. As in our study, we are using the response variable math, and factor variable is program. Then click on submit and it will give you the same result that we are getting through the command option. So as you can see that we have applied one way ANOVA and it has indicated that at least one mean is different, and now we want to identify that which mean is different from the uh, rest of the other means. So how to identify that which mean is different from the other? So what is the command is pw mean math power program 2 and then effect. So we are going to copy this command and we are going to paste it here. Now you can see that it has showing that the total number of comparison are 3, as we have 3 programs. The first comparison is between journal versus academic, then vocational versus academic, and vocational versus journal. And when you look at the p-values, the first two programs comparison p-value is less than 0.05, but when you look at the last value, it means that the last value program is 0.08, which is greater than 0.05. So it means that vocational versus journal programs mean is not different, but the mean of journal versus academic and vocational versus academic is different. So only the mean of vocational versus journal program is not different. So it means that vocational and journal program means are same. So if we look at that, how much the difference is between the journal versus academic program, that is minus 6.7. And what is the difference between vocational and academic, that is -10. So if we want to see the mean in a table, so how can we do it? We can also simply write this command, tabulate math, tabulate program 2 and summarize math. So it will give us the mean of all the programs. So here is the mean of academic, here is the mean of general, and this is the mean of vocational. So when you look at the academic and general means, you can see that their mean is much higher as compared to the vocational mean. So this is how you can apply the one way ANOVA on your data set.